Okay, find carbon on the periodic chart. It's atomic number 6. What's the atomic mass? Okay, so we saw carbon, atomic number 6, a mole of carbon. A mole of carbon is 12.01 grams. It's grams per mole, you could write it as. You remember from the last tape, a mole is 6.02 times 10 to the 23rd atoms. So a mole of carbon weighs that. 12 grams, that's a small amount of mass. Remember, a whole pound is 454 grams. What does a single atom of carbon weigh? This is a mole of carbon. It weighs 12.01 AMUs. And remember, we could take the 12.01 AMUs and convert it to grams by saying 1 AMU is 1.66 times 10 to the minus 24 grams. And we could solve that and our answer would be in grams. What happens if we start with 36.03 grams of carbon? And we want to know how many moles that is. Here's what we're starting with, and what we want to know on the left is moles of carbon. Conversion factor. 1 mole. We want to put grams of carbon down here so it cancels out. And we're going to put moles of carbon here because that's what we want. Moles of carbon. So what numbers go in here? 12.01 grams is the weight of 1 mole. So you see, I made it come out very nicely as 3 moles. If we want to know how many atoms that 3 moles is, we could continue right on, but I'm out of room, so I'm going to say 3 moles of carbon. And we want to know how many atoms of carbon that is. Good old dimension analysis. Put what we want to get rid of in the denominator, moles of carbon, it's gone. Put what we want in the numerator, atoms of carbon. And 1 mole is 6.02 times 10 to the 23rd. So 3 times that is 18.06 times 10 to the 23rd atoms of carbon, or 1.806 times 10 to the 1. It becomes 1.806 times 10 to the 24 atoms of carbon. What do you think? Simple conversions. Now what happens if we have a mole of oxygen atoms? Same thing. You have look up the periodic chart. That's 16 grams per mole. 16 grams per mole. Okay. How many atoms is that? 1 mole. 1 mole of anything is the same thing. 6.02 times 10 to the 23rd atoms. Atoms of oxygen. And let's put it all together. Let's put it all together. Let's take the carbon and oxygen. Carbon and oxygen, and make a very common compound, carbon dioxide. In a solid form, it's called dry ice. Dry ice. It's the primary compound in respiration of animals. Okay, let's play some games here. When we put carbon and oxygen together, we have what is called a molecule. This is two or more atoms chemically combined, bonded together. So if we have one, let's say 3 molecules of carbon dioxide, what we have is 3 carbon atoms, and 3 times 2, 6 oxygen atoms. That makes sense? So the single unit is a pure substance. It's a compound or a molecule. If we have 3 moles of carbon dioxide, now let's look what we have. We have 3 moles of carbon atoms. Instead of 3 single atoms, we have 3 moles of carbon atoms, and we have 6 moles of oxygen atoms. And you could get the weight. If we wanted to get the weight of 1 mole of carbon dioxide, the weight, it would be 1 mole of carbon, which is 12.01 grams, 2 moles of oxygen, which is 16 times 2, 32 grams. Add it together, and you have 44.01 grams per mole. Let's look at the molecules. If you have 1 mole of carbon dioxide, you have, once again, 6.02 times 10 to the 23rd molecules. A mole of anything is 2 things. And we're going to stick this right in the middle here. 1 mole of anything. When we talk about it, it has 2 things. A mole has a count, and it has a mass. A mole of anything. We'll circle that in there, right in the middle. The count's always the same. 6.02 times 10 to the 23rd. The mass depends upon the mass of the atoms. If it's an element, you just get the mass of the element. If it's a molecule, it's the combinations of the atoms that make up the molecule. So we're going to stop right there, and we'll continue working with